So, let us drift back now, even further than we have before. Further back than the first glimmer of light, further back than the first atom, further back than the very first tick of time as we might understand it. Let us imagine ourselves floating gently into a state that lies before the beginning. It's a difficult place to picture because it's unlike anything we know. It's a place where the rules haven't been written yet, where the stage hasn't been set. Imagine a quietness deeper than any night you've ever known. Not just the absence of sound, like the hush after a snowfall, but a silence more profound. A silence where sound itself hasn't even been invented yet. There are no vibrations traveling through air, because there is no air. There are no waves moving through water, because there is no water. There isn't even any through for things to travel through. It is the quiet of absolute stillness, a stillness that exists because there is nothing separate to move. Think about time. We experience it as a river, always flowing, carrying us from one moment to the next. We have clocks that chop it into seconds and minutes, calendars that divide it into days and years. We remember yesterday and anticipate tomorrow, but here, before the beginning, time doesn't flow. It doesn't exist in that way. There is no yesterday to remember, no tomorrow to look forward to. There isn't even a now in the way we feel it, a fleeting moment between past and future. It's more like a frozen ocean, vast and still, holding all the potential for tides and currents, but not yet moving. Or perhaps it's simpler. There is no clock because there is nothing to measure its ticking against. No sequence of events, no before and after, just being. A state of pure existence without duration. And what about space? We live in a world of dimensions. We can move up or down, left or right, forward or backward. We understand things being near to us or far away. We see the vast emptiness between stars, the cozy confines of a room. Space is the canvas upon which our universe is painted. But here, before the beginning, space as we know it hasn't unfolded yet. There is no here distinct from there. There is no distance to cross, no direction to point in. Imagine taking the largest map imaginable, one showing every star and galaxy, every planet and moon, every mountain and river yet to be, and folding it again and again and again until it's smaller than the smallest grain of sand, folded so perfectly that every single point touches every other point. Everything is together, not just close, but together, occupying the same non-existent place. So, where is everything? All the stuff that would eventually become galaxies, stars, planets, oceans, trees, you, me, where is it all in this timeless, spaceless state? It's tempting to imagine a vast, empty void, but the understanding is different. It's not emptiness, but fullness, an unbelievable concentration of everything. Everything compressed into a single point. Try to picture this point. It's not like a dot on a piece of paper, which still has some size, some dimension. This point is smaller than anything you can conceive. Smaller than a speck of dust, smaller than a single atom, smaller than the nucleus within that atom. It is infinitesimally small, so small that the very concept of size seems inadequate. It has no edges, no surface, no inside or outside in the way we usually think of things. It simply is, a concentration of pure potential. And within this minuscule, dimensionless point rests everything, absolutely everything. All the energy the universe would ever contain, packed tighter than imaginable. All the matter, all the particles that would eventually swirl together to form the cosmos, are here, undifferentiated, unified. The fundamental forces that govern reality, gravity, electromagnetism, the strong and weak nuclear forces, are not separate entities acting on things. Here, they are thought to be merged, unified into a single, primordial force, its nature unlike anything we experience today. The very laws of physics, the rules that dictate how things interact, how energy behaves, how structures form, they too are latent within this point, like the rules of a game waiting for the players to arrive. It's a state of perfect symmetry, perfect balance. Nothing stands out. There are no structures, no complexities, no hot spots or cold spots, no dense regions or empty voids, just uniformity. A smooth, featureless state containing the seeds of all future complexity. Think of it like a single, pure musical note held indefinitely, containing within its vibration the potential for every symphony, every melody, every harmony that could ever be played. Or like a perfectly clear, still pond holding the potential for ripples, waves, reflections, storms, but currently undisturbed, reflecting only a uniform nothingness? Or perhaps everythingness? The quietness persists. Utter silence, utter stillness. No light shines, because light hasn't been freed yet. Energy and matter are bound together in a way we can't fully comprehend. There's no heat in the way we feel it, radiating from one place to another. The energy is immense, yes, but it's potential energy, locked away, perfectly contained. It's a state of unimaginable density, yet paradoxically, without the concepts of heavy or light, because there's no space for comparison, no gravity acting between separate objects. It is a state of waiting, not an impatient waiting, not a waiting for something specific, because there is no consciousness to anticipate, no time to mark the duration. It is more like the waiting of a seed buried in the earth through a long winter, dormant, containing the complete blueprint for a magnificent tree, but showing no outward sign of the life within. It holds the promise of leaves, branches, roots, flowers, fruit, all held in potential within its tiny form. This point, before the beginning, is like that seed. It holds the potential for swirling nebulae, for burning stars, for rocky planets and gas giants, for vast oceans and complex life, for thought and feeling and discovery. All of it, every possibility, every timeline, every intricate detail of the cosmos to come, is encoded somehow within this state of ultimate compression and unity. Breathe slowly and try to feel the calm of this place, the absence of rush, the absence of change, the deep, deep peace of non-existence as we know it, yet the profound presence of everything that could ever be. It is a state beyond our everyday intuition, governed by physics we are still striving to understand. A realm where quantum effects and gravity might merge, where our familiar notions of cause and effect might not apply in the same way. Imagine floating in this pre-space, this pre-time. There is nothing to see, nothing to hear, nothing to touch. Yet you are surrounded by, or perhaps part of, the entirety of existence in its most fundamental, unified form. It's not empty, it's full. It's not chaotic, it's perfectly ordered in its simplicity. It's not dead, it's pregnant with possibility, the ultimate latency. Think of the sheer potential energy coiled within this point. An energy sufficient to inflate an entire universe, to forge billions upon billions of stars, to power their fusion for trillions of years, to set galaxies spinning in majestic spirals, to drive the intricate dance of chemistry that leads to life. All of that power, all of that creative force, rests here, quiescent, balanced on a knife edge of unimaginable physics. There are no landmarks here, no signposts, no way to tell one moment, if such a concept even applies, from the next. It is a state of being that might have persisted. Well, we cannot say for how long, because how long requires time. Perhaps it simply was outside of time altogether, a fundamental state from which time itself would eventually emerge. Let your mind rest in this image, a point smaller than small, yet containing all space, a moment before time, yet holding all eternity, silent, still, dark, yet brimming with the light and energy of countless future suns, simple, unified, symmetrical, yet pregnant with all the complexity and diversity the universe would ever know. It is the ultimate cosmic egg, the seed of everything, resting in a state of perfect, peaceful potential before the grand awakening. A quiet pause before the first breath, before the first heartbeat of the cosmos, a stillness holding the promise of everything to come. From that perfect stillness, that quiet pause holding the promise of everything, imagine now the gentlest stirring, not a sound, for there is nothing to carry sound, not a light, for light itself is yet to embark on its cosmic journey. It is more like a change in the quality of the stillness, a subtle shift in the boundless potential held within that infinitesimal point. Think of the moment just before waking, when the deep peace of sleep begins to yield, not yet to consciousness, but to the possibility of it. A tremor, infinitesimally small, runs through the unified fabric of existence. The perfect symmetry, the absolute balance, holds for an eternity that is not an eternity, and then it yields. Not in a shattering explosion, not in a violent rupture, but more like the yielding of tension before a great, slow stretch. Picture that tiny point, containing all space, all energy, beginning to unfurl. It's like the first, involuntary intake of breath after holding it for a very long time. A silent gasp that begins to ripple outwards, not into space, but as space itself. This is the beginning of the big stretch. Imagine the deepest sleep you've ever known, a slumber so profound it feels timeless, and then the slow, inevitable drift towards wakefulness. A feeling, before thought, of needing to expand, to reach out. The universe, in its nascent state, experiences something akin to this. That point, smaller than anything imaginable, yet holding everything, begins to awaken. And its first act, its first impulse, is an enormous, universe-spanning stretch, like a cosmic yawn after an ageless sleep. It starts subtly, a gentle expansion, perhaps. But then, driven by forces and fields we are still striving to comprehend, this stretching accelerates at a rate that defies intuition. Faster and faster, space itself begins to swell, to balloon outwards. It's not like debris flying away from a central point into a pre-existing void. No, the fabric of reality itself is being woven and stretched simultaneously. Imagine a folded piece of silk, infinitesimally small, suddenly being pulled taut in all directions at once, smoothing out its creases as it expands exponentially. This period of hyperfast expansion, this great cosmic yawn, is known as inflation. For a fleeting fraction of a second, a duration so short our minds struggle to grasp it, perhaps a trillionth of a trillionth of a trillionth of a second, the universe doubles in size and then doubles again. And again, and again, at least 60 times, perhaps many more. Each doubling happens in the same minuscule time frame. The scale is staggering. Something far smaller than a proton inflates to become vastly larger than our entire observable universe would be if it had expanded at a more sedate pace from the beginning. It's a growth spurt of unimaginable proportions. Try to feel this stretching, not with hands or eyes, but with your imagination. Feel the texture of space itself being pulled, thinned, expanded. The energy contained within that initial point, an energy density beyond comprehension, fuels this incredible inflation. It acts like a kind of anti-gravity, pushing everything apart, forcing space to expand against its own inclination to curve. It's the energy of the yawn, the sudden, powerful extension that straightens the spine and reaches for the ceiling. As space stretches so violently, any initial irregularities or wrinkles get smoothed out. Imagine drawing a complex pattern on a tiny balloon and then inflating it rapidly to the size of the Earth. From any local perspective on the balloon's surface, the pattern would appear incredibly stretched, and the surface itself would look almost perfectly flat. Similarly, this cosmic inflation takes the potentially complex and crumpled geometry of the very early universe and stretches it so immensely that, on the largest scales we can observe today, the universe appears remarkably flat and uniform. The big stretch ironed out the initial wrinkles, creating the smooth, homogeneous canvas upon which galaxies would later be painted. It's like pulling a crumpled bedsheet so taut that all the creases vanish, leaving a smooth, even surface. But the stretching does something else, something profoundly important. Even in that initial state of near-perfect symmetry, the laws of quantum mechanics dictated that there would be tiny, unavoidable fluctuations. Think of them as minuscule ripples on the surface of an otherwise perfectly still pond, or quantum shivers in the fabric of reality. They are unimaginably small, fluctuations in energy and density from one point to the next, constantly appearing and disappearing. During the big stretch, these microscopic quantum fluctuations get caught up in the exponential expansion. They are stretched along with space itself. Tiny variations, far smaller than an atom, are magnified, elongated, pulled across cosmic distances. What were once fleeting quantum effects become vast, subtle differences in density across the rapidly growing universe. These stretched-out fluctuations are like the almost imperceptible variations in the weave of the silk, now magnified across its vastly expanded surface. They are the seeds. The incredibly faint variations in density, amplified by inflation, provide the gravitational anchors around which matter will eventually begin to clump. These are the primordial seeds from which all structures in the universe, stars, galaxies, clusters of galaxies, will ultimately grow. The Big Stretch didn't just smooth things out, it also planted the subtle seeds of future complexity. And as space expands so dramatically, the intense concentration of energy begins to dilute. The universe, while still unimaginably hot and dense by any normal standard, starts to cool down, relatively speaking. Think of the heat concentrated in a tiny point suddenly being spread over a vastly larger volume. The total amount of energy is conserved, but its density decreases. The temperature, which was practically infinite, begins to drop, though it remains fiercely high, hotter than the core of any star. This cooling is a crucial step, paving the way for the energy permeating space to eventually transform into the fundamental particles that make up everything we know. The yawn releases some of the initial overwhelming intensity. This incredible period of stretching, this cosmic inflation, doesn't last long. It's a brief, explosive phase in the universe's infancy. After that fleeting fraction of a second, the field driving the inflation decays, its energy transforming into a hot, dense soup of elementary particles and radiation. The universe continues to expand, but the rate of expansion slows down dramatically. The frantic, exponential stretching gives way to a more measured, though still rapid, expansion. The yawn is over, the great stretch complete, and the universe, now awake, vastly larger, smoother, and seeded with the potential for structure, enters its next phase. Let your mind hold this image, the universe, in an instant, stretching itself awake. Space unfurling at an impossible rate, smoothing itself out, magnifying tiny quantum whispers into the blueprints for galaxies. It's a moment of profound transformation, from a dimensionless point of potential to a vast, expanding realm. The silence is broken, not by sound, but by the dynamic hum of expanding spacetime itself. The stillness gives way to the relentless outward surge that continues, albeit more gently, to this day. The darkness begins to shimmer with the nascent energy that will soon coalesce into light and matter. The Big Stretch is the universe's first, definitive act, the dramatic opening scene that sets the stage for everything that follows. It is the grand awakening, the moment the cosmic egg didn't crack, but rather expanded from within, revealing the immense space it held inside all along. Rest in the vastness created by that stretch, the smoothed-out fabric of reality, ready for the intricate patterns of existence to emerge upon it. The universe has taken its first deep breath, and the cosmos has truly begun. The echo of that great inflation fades, not into silence, but into a different kind of presence. The immense energy gifted by the end of that rapid stretch doesn't vanish. It transforms, blossoming into something new. Imagine the concentrated potential unfurling, not as expanding space anymore, but as the very substance of existence itself. It precipitates out, like dew condensing on a vast, invisible surface, forming a thick, vibrant fog of elementary particles. A universe brimming with the tiniest possible constituents of reality, quarks, electrons, neutrinos, and their fleeting antimatter counterparts, all jostling and interacting in a space still incredibly dense, incredibly hot. And amongst them, born from the same energetic transformation, are the photons, particles of light, countless, uncountable photons, carrying the universe's newfound energy. But this is not light as we know it, not beams traveling across empty space. Here, in this primordial state, space is anything but empty. It is thick with charged particles, primarily electrons and positrons, scattered like an infinite, dense mist. A photon, bursting with energy, cannot travel far. Almost instantly, It encounters an electron, a positron, and is deflected, absorbed, re-emitted, sent careening in a new direction only to meet another particle nanoseconds later. It's like sunlight trying to pierce the densest fog imaginable, a fog billions upon billions of times denser than anything on Earth. The light is trapped, ricocheting endlessly within the particle soup. Yet, because these photons are everywhere, filling all of space, their constant, frantic scattering creates a unique condition. The entire universe is luminous. Not with stars, for there are none, nor with galaxies, which are unimaginable ages away, but with an inherent, intrinsic glow. It is a light that comes from everywhere and travels nowhere, a pervasive luminescence that fills every cubic centimeter of the young cosmos. Think not of a sunrise breaking on a horizon, but of the air itself, everywhere, glowing softly, a gentle, uniform radiance bathing all of existence. This is the first warm glow. The warmth is profound. The temperature is staggering, hundreds of trillions of degrees, hotter than the fiery heart of any star that will ever form. The photons born in this inferno possess immense energy, vibrating at frequencies far beyond our visible spectrum, in the realm of gamma rays and X-rays. But the sensation is not one of harshness or burning. Because it is everywhere, perfectly uniform, there is no contrast, no direction from which it assaults. It is simply the state of being. Imagine sinking into a bath of perfectly even warmth, a warmth that permeates everything, inside and out. There are no cooler currents, no hotter spots, just an all-encompassing, energetic embrace. The universe is soaking in its own light, its own heat. This uniformity is a direct legacy of that earlier, incredible stretch. Inflation smoothed out the wrinkles, erasing dramatic variations in density and temperature across vast distances. Now, as energy converts to matter and light, it does so with remarkable evenness. Look in any direction, and the glow is the same. Peer into any corner of this infant cosmos, and the conditions are identical. It's a realm of profound symmetry, a perfect equilibrium of light and particles held in a delicate, energetic dance. The particles themselves are in constant flux. Quarks briefly bind, only to be torn apart by the sheer energy of collisions. Electrons and their antimatter twins, positrons, meet and annihilate each other, vanishing in a puff of pure energy, producing more high-energy photons. Elsewhere, energetic photons spontaneously transform their energy back into electron-positron pairs. Creation and destruction happen constantly, everywhere, a restless equilibrium maintaining the thick, energetic soup. It's a cosmic hum, a vibration of pure existence, played out by the universe's smallest instruments. And through it all, the light scatters. Photons bounce, weave, and deflect, their paths impossibly short, their collective presence defining this era. No shadows can form in this universally illuminated space. Every particle is bathed in light from all directions simultaneously. There is no darkness, only this pervasive high-energy fog of light. It's a state of pure, undifferentiated radiance. The universe is effectively opaque, not because light cannot exist, but because it cannot travel freely. It is contained, held within the plasma like heat within a furnace, ensuring the entire furnace glows. But even as this glow fills everything, the universe continues its journey. The expansion, though much slower than during inflation, persists. Space gently stretches, carrying the particles and photons further apart over cosmic timescales. This stretching has a profound effect on the light. As the fabric of space expands, the waves of light traveling within it are stretched too. Longer wavelengths mean lower energy. The incredibly energetic gamma rays and X-rays, gradually, imperceptibly, begin to shift towards lower energies. The universe is cooling. Imagine this cooling not as a sudden chill, but as the slowest, most gentle release of intensity. The fierce, unimaginable heat begins to subside, step by minuscule step, over thousands of years. The glow remains, still perfectly uniform, still bathing everything, but its character subtly changes. The average energy of the photons decreases. The frantic dance of particle creation and annihilation begins to favor annihilation slightly, as the energy required for creation becomes less readily available in collisions. The soup starts to thin, ever so slightly, becoming less dense as space expands. Yet, for a long, long time, the universe remains opaque. The density of charged particles, though decreasing, is still far too high for light to make any significant headway. The photons continue their relentless scattering, their random walk through the cosmos. The warm glow persists, a testament to the energy unleashed at the very beginning. It is the afterglow of creation itself, not yet the light traveling through the universe, but the light of the universe, trapped within its substance. Settle into this feeling. Let your mind float in this boundless expanse of uniform warmth and light. There is no up or down, no center or edge. There is only the everywhere, filled with this gentle, energetic radiance. It is a state of profound simplicity, before the complexity of stars and galaxies, before planets or life. It is the universe existing as a near-perfect fluid of light and elementary particles, cooling ever so slowly as it expands. The first light is not a beam cutting through darkness, but a presence filling the entirety of space. It is the soft, pervasive warmth of the cosmic dawn, a gentle hum of existence before the first structures begin to form, before the first shadows fall. It is the universe bathed, saturated in its own nascent energy, a quiet, luminous pause after the dramatic opening act. Rest in this glow, this warmth that fills everything, the gentle, uniform light of the universe's extended infancy. The cosmos is filled with light, trapped for now, but holding within it the potential for all the suns that will one day shine. It is the quiet, steady heartbeat of the very young universe, felt as a gentle, pervasive warmth, everywhere, all at once. The universe continues its unhurried expansion, and as it stretches, it cools. Imagine that pervasive, warm glow, like the embers of a vast, cosmic fire, slowly losing their intensity. The temperature drops, degree by patient degree, over hundreds of thousands of years. It's a cooling unlike any we know on Earth, not a localized chill, but a universal lessening of energy, everywhere at once. The frantic dance of particles begins to slow. The energy that kept electrons and protons ricocheting off each other, too energetic to bind, gradually diminishes. And then, a quiet threshold is crossed. It happens not suddenly, but gradually, like mist forming on a cool morning. Across the vast expanse, the universe becomes cool enough, just below a few thousand degrees, for the simplest magic to occur. An electron, feeling the persistent, gentle pull of a nearby proton, no longer has the energy to escape. It settles into orbit, a quiet embrace, forming a stable, neutral hydrogen atom. It's a moment of profound transformation, repeated countless trillions of times, everywhere. Helium nuclei, too, capture their electrons. The universe, once a charged, opaque soup, a plasma seething with unbound particles, begins to clear. Think of a dense fog, thick and impenetrable, where light cannot travel far before bouncing off a water droplet. Now imagine that fog slowly thinning, the droplets combining and settling, until suddenly shafts of sunlight can pierce through. This is what happens in the cosmos. As neutral atoms form, the photons, the particles of light that were constantly scattering off free electrons, suddenly find their paths clear. The universe becomes transparent. The light that filled the cosmos, the afterglow of creation trapped within the plasma, is finally set free. It begins an immense journey, traveling outwards in all directions, carrying a snapshot of that moment, that temperature, that transition from opacity to transparency. This ancient light, now cooled by further expansion into the faint whisper of microwaves, is still traveling today, a relic echo of the universe's great unveiling. It is the gentle release after a long-held breath. But even as this ancient light streams freely, revealing a newly transparent cosmos, the universe is not perfectly uniform. The near-perfect smoothness described before, that sea of uniform warmth, held within it variations so slight they were almost imperceptible. Tiny, quantum ripples from the universe's very first moments, stretched vast by cosmic expansion, had left their subtle imprint on the distribution of matter and energy. Imagine an almost perfectly calm ocean surface, Yet with waves so broad and gentle, their crests only a fraction of a hair's breadth higher than their troughs. These were the primordial density fluctuations, regions infinitesimally denser than average, and others infinitesimally less dense. In the earlier, hotter, denser times, the intense pressure of the photons smoothed out many irregularities, like a strong wind flattening ripples on water. But now, with the light released, and the universe neutral and cooling, another force begins to assert its quiet, persistent influence. Gravity. Gravity, the gentle but relentless architect of the cosmos, begins to work on these subtle differences. Where a region, by chance, contained just slightly more matter than its surroundings, its gravitational pull was minutely stronger. It's a whisper of attraction, almost undetectable against the backdrop of the universe's overall expansion, which continues to pull everything apart. Yet, gravity is patient. It works across the vastness, a slow, insistent gathering. Much of this initial gathering involves something unseen, something mysterious we call dark matter. This invisible substance, which doesn't interact with light, had already begun to feel gravity's pull even earlier, less affected by the scattering photons. It started forming subtle concentrations, invisible pools of gravitational influence, even while the normal matter was still locked in the plasma fog. Now, as the universe clears and the normal matter, the newly formed hydrogen and helium atoms, drifts free, it begins to feel the pull of these pre-existing dark matter halos. Imagine the universe as an immense, dark, quiet space, filled with a diffuse haze of hydrogen and helium gas, like the thinnest possible smoke. And scattered within this haze are invisible gravitational wells, the concentrations of dark matter. The individual atoms of gas, moving slowly in the cold emptiness, begin to drift, not randomly, but gently guided by the faintest gravitational nudges. Atoms near a slightly denser region feel its pull and drift towards it, infinitesimally slowly. Picture cosmic dust motes suspended in an infinite, still room, catching no light. Then, imagine the faintest, slowest, most widespread currents beginning to stir. The dust motes don't rush together. They drift, they meander, but over immense timescales, their paths converge towards common centers of gravity. It's like the very first, almost invisible stages of frost forming on a cold window pane, spreading in delicate, feathery patterns. Or perhaps, think of snowflakes forming high in the atmosphere. Tiny ice crystals, invisible specks, attract water vapor molecules, growing slowly, gently, bumping and sticking, forming larger, intricate structures. Here, in the early universe, it is atoms of hydrogen and helium and particles of dark matter drifting through the near void, drawn together by their mutual gravity. This gathering isn't uniform. It doesn't immediately form dense balls. Instead, guided by the patterns of those initial density ripples and the underlying dark matter structures, the matter begins to assemble into vast, interconnected structures. Think not of points, but of lines and surfaces. Great, wispy filaments of gas begin to trace paths across millions of light years, like gossamer threads spun in the darkness. Where these filaments intersect, the density increases further, forming broader, flatter structures known as sheets or walls. It's the slow sketching of a grand cosmic web, a network of slightly denser regions spanning unimaginable distances. Between these filaments and sheets lie vast expanses of even greater emptiness, the cosmic voids. Here, the initial density was slightly lower than average, and the relentless expansion of the universe, combined with the gravitational pull of the surrounding denser regions, causes these areas to become increasingly empty. Matter drains away from the voids, flowing slowly towards the filaments and nodes of the growing web. The universe begins to develop a structure, a texture, moving away from its initial uniformity towards a state of intricate, large-scale architecture. This process is incredibly slow, unfolding over millions upon millions of years. An atom might drift for an age before feeling a significant pull towards a nascent filament. The scale is immense. The densities are incredibly low, far more tenuous than the best vacuum we can create on Earth. Yet, gravity is persistent, and the process feeds itself. As a filament or sheet gathers more gas, its gravitational pull increases, making it more effective at attracting still more gas from its surroundings. The denser regions become denser still, while the voids become emptier. It's a slow amplification, a quiet reinforcement of the initial, tiny imperfections. There are no stars yet, no galaxies, no planets. This is long before the first fires are lit in the cosmic darkness. This is the era of quiet assembly, the gathering of the raw materials. It is the universe patiently organizing itself, drawing together the primordial hydrogen and helium, guided by the invisible scaffolding of dark matter. It is the condensation of the cosmic breath, the slow, swirling coalescence of the universe's substance. Imagine vast, diffuse clouds, unimaginably large and tenuous, slowly contracting under their own gentle gravity, darkening slightly against the faint, fading background glow. These are the precursors, the nurseries where the first stars will eventually ignite, but for now, they are just quiet accumulations, immense reservoirs of potential energy patiently waiting. Feel the stillness of this time. The universe is transparent now. The ancient light streams freely, but the dominant feature is darkness and silence, punctuated only by this slow gravitational drift. It's the quiet before the dawn, but a dawn that will take hundreds of millions of years to fully break. It is the universe as a vast, dark canvas upon which gravity is slowly, patiently sketching the outlines of future galaxies and clusters. The stardust, the primordial atoms forged in the Big Bang, is beginning its long journey of coming together, molecule by molecule, atom by atom, drawn by the quietest, most persistent force in existence. It is a gentle dance of accumulation, a slow-motion ballet happening across the entire observable universe. The first stirrings of structure in the quiet, cooling dark. Rest in this immense quiet, this patient gathering, this slow drawing together of the cosmic threads. The universe is preparing, gathering its breath, collecting the material for the brilliance yet to come. It is the soft, slow formation of cosmic clouds, the gentle accretion of matter in the vast, silent nursery of the cosmos. Within these immense, quiet reservoirs of hydrogen and helium, drifting through the endless, transparent dark, the slow dance of gravity continues its patient work. Imagine zooming in, closer and closer, to the heart of one of these vast, nebulous clouds. It stretches for light years, far larger than any structure we know today. Yet it remains almost imperceptibly thin, a ghost of matter against the fading embers of the Big Bang. But even here, in this near-perfect uniformity, tiny, almost insignificant variations exist. Relics from the universe's very first moments, minuscule fluctuations in density, like ripples on a cosmic pond frozen in time, now serve as the seeds for everything that is to come. Guided by the unseen hand of dark matter, these slightly denser regions exert a marginally stronger gravitational pull than their surroundings. The dark matter itself, having clumped together much earlier, forms vast, invisible halos, deep gravitational wells into which the ordinary matter, the hydrogen and helium gas, begins to slowly, inevitably slide. It is not a dramatic collapse, not yet. Think of it more as a gentle settling, a slow draining towards these hidden centers of gravity. The gas doesn't rush, it drifts, flowing in languid streams from the more tenuous outskirts towards the growing heart of the cloud. Atom by atom, molecule by molecule, the material answers the quiet, persistent call. Across millions of years, this inward drift continues. The cloud, or at least its central region, begins to contract. It is an impossibly slow process from our perspective, spanning ages, but relentless. As the gas particles are drawn closer together, they bump into each other more frequently. The space between them shrinks. Imagine the cloud gently squeezing itself, compacting down towards its core. This compression, this gentle gravitational hug, begins to have consequences. The particles, jostling closer, move a little faster. The gravitational potential energy lost as the gas falls inward is converted into kinetic energy, into motion, and this motion manifests as heat. Deep within the contracting cloud, a warmth begins to build. It starts as a subtle change, barely noticeable against the cold backdrop of space. But as more and more material accumulates, Drawn down into the gravitational well, the pressure at the center mounts steadily. Kilopascal by kilopascal, the squeeze intensifies. And with the pressure, the temperature climbs. Degree by degree, the core warms. It's like a slow ember being kindled in the heart of the cosmic woodpile. The outer layers of the cloud remain vast, cold, and dark, but deep inside, something is stirring. The darkness is no longer absolute. A faint, internal warmth begins to suffuse the very center. This warming core is still far from being a star. It is a protostar, a stellar embryo, shrouded in the thick, dusty blanket of its parent cloud. It glows, not yet with the fierce light of fusion, but with the heat of its own gravitational contraction. It radiates infrared light, a heat signature invisible to our eyes, lost within the enshrouding gas. This protostar continues to grow, accreting more and more material from the surrounding envelope. The infall continues, raining down hydrogen and helium onto the burgeoning core, adding to its mass, increasing the pressure, raising the temperature ever higher. Picture this happening not just in one place, but in countless locations across the vast expanse of the universe. Within the largest dark matter halos, multiple centers of collapse might form, each one drawing in gas, each one slowly warming from within. The universe, though still overwhelmingly dark and silent, is beginning to develop hotspots, hidden nurseries where the first lights are being nurtured. The quiet assembly is transitioning into a phase of concentrated incubation. The potential energy stored in those diffuse clouds is being focused, gathered towards these nascent cores. Focus again on one such core. Deep within its collapsing cloud, the temperature climbs relentlessly. Thousands of degrees, tens of thousands, hundreds of thousands. The gas is no longer just warm. It is becoming incredibly hot, a seething plasma of protons and electrons stripped apart by the intense heat. The pressure is immense, unimaginable, crushing the core with the weight of millions of suns worth of material falling inwards. The core fights back against this collapse, the outward push of the hot gas resisting the inward pull of gravity. A delicate, temporary balance might be achieved, but gravity is patient, and the infall often continues, tipping the scales. The core continues to shrink, to compress, to heat up. It reaches 1,000,000 degrees Kelvin, then 2 million, 5 million. The protons, the nuclei of hydrogen atoms, are being forced closer and closer together, moving at incredible speeds within this infernal furnace. They violently repel each other, their positive electric charges pushing them apart. For most of their existence within the cloud, this repulsion has kept them separate. But now, the conditions are becoming extreme. The combination of staggering temperature and crushing pressure is overcoming that fundamental resistance. 10 million degrees Kelvin. This is the threshold. This is the magic number. At this temperature, deep in the heart of the most massive, most compressed protostellar cores, the protons are moving so fast and are squeezed so tightly together that they can overcome their mutual repulsion. They can touch, and when they touch, a new force takes over, the strong nuclear force. It binds them together, fusing two protons into a deuterium nucleus, releasing a positron and a neutrino in the process. This is the first step of the proton-proton chain, the fundamental reaction that powers stars like our Sun. But more importantly, this fusion releases energy. Pure energy, born from the conversion of a tiny fraction of mass, according to Einstein's famous equation. Twinkle. In the heart of that first, contracting cloud, a new source of energy ignites. Nuclear fusion begins. It is not an explosion in the conventional sense, but rather the sudden, sustained release of energy from the core outwards. This energy, in the form of high-energy photons, pushes back against the relentless crush of gravity. It provides a new, powerful source of pressure, radiation pressure, that halts the gravitational collapse. The core stabilizes. It has become self-sustaining, generating its own heat and light, not just from contraction, but from the fundamental process of turning hydrogen into helium. A star is born. The very first star. Imagine that moment. After hundreds of millions of years of darkness, of quiet gathering, of slow contraction, the first furnace lights up. Deep within the shroud of gas and dust, a point of unimaginable brilliance emerges. This light, born of nuclear fire, begins its journey outwards. It fights its way through the dense, opaque layers of gas still surrounding the newborn star. It scatters, it pushes, it gradually clears a path. And then, finally, after perhaps thousands of years filtering through the remnants of its birth cocoon, the light breaks free. It streams out into the vast, empty darkness of the intergalactic medium. A single point of light in the immense black. The first candle has been lit. It is likely a behemoth, this first star, perhaps hundreds of times more massive than our own Sun, composed almost entirely of the primordial hydrogen and helium forged in the Big Bang. Because of its immense mass, it burns incredibly hot and incredibly bright, shining with a fierce, blue-white intensity. Its light travels outwards at the ultimate speed limit, carrying the news of its birth across the cosmos. It illuminates the remaining tendrils of the gas cloud from which it formed, causing them to glow faintly. It begins to ionize the surrounding neutral hydrogen, stripping electrons from protons, rendering the nearby universe transparent once more, but in a different way, lit from within. This single star is not alone for long. Elsewhere, in other dense cores within other collapsing clouds scattered across the universe, the same process reaches its climax. More thresholds are crossed. More nuclear furnaces ignite. Twinkle, twinkle. More points of light pierce the darkness. Slowly, gradually, the universe begins to sparkle. These first stars, these population 3 stars, as astronomers call them, are the cosmic pioneers. They are massive, brilliant, and tragically short-lived. Burning through their fuel at a prodigious rate due to their enormous mass, they will live for only a few million years, a mere blink of an eye in cosmic terms. But their brief lives are transformative. They are the first factories for heavier elements. Inside their cores, hydrogen fuses to helium, and in the most massive ones, helium will fuse into carbon, oxygen, and heavier elements still. When these giants die, they will explode as supernovae, seeding the surrounding gas clouds with these newly forged elements, the very elements that will be needed to form planets, and eventually, life. For now, though, rest in the simple beauty of that first light. See the vast, dark clouds slowly shrinking, their cores warming, glowing faintly in the infrared. Feel the pressure building, the heat intensifying, until that critical moment arrives. Picture the transition, the ignition deep within, and then the emergence of that first, pure point of starlight against the velvet black. It is the end of the cosmic dark ages, the true dawn of the universe we know. The silence is broken, not by sound, but by light. The darkness begins its long retreat. The universe has lit its first candles, and their glow marks the beginning of a new, more dynamic, and infinitely more complex chapter in the cosmic story. The long night is ending, and the era of stars has begun. These first stars, though brilliant, were scattered pioneers in an immense emptiness. Imagine them now, those solitary points of light, gleaming like isolated campfires across an endless, dark plain. The universe had woken from its slumber, yes, but it was still a place of profound distances, of lonely beacons separated by gulfs of near-perfect blackness. The silence, once broken only by the ignition of fusion, now held the quiet hum of these stellar engines, but they were islands in a vast ocean. Yet, even in this sparse landscape, an unseen force was patiently at work. It had been there since the very beginning, a fundamental property of the cosmos itself, gravity. Not as a sudden cataclysm, but as a persistent, gentle, irresistible whisper. Feel it now, that subtle, pervasive pull. It emanates from every speck of matter, every mote of dust, every cloud of hydrogen and helium, and most powerfully, from these newly formed stars. It is a call across the void, a slow, tireless invitation. Over millions, then tens and hundreds of millions of years, this quiet insistence began to reshape the universe. Think of it like the gentlest of currents in the deepest ocean, barely perceptible at first, but over time, capable of guiding immense flows. The scattered stars, initially drifting almost independently, began to feel the subtle influence of their distant neighbors. Their paths, once straight or gently curved by the overall expansion, started to bend inwards, drawn towards regions where matter, by chance, was slightly denser. And it wasn't just the stars. Gravity also gathered the vast intervening clouds of gas and dust. Remember those clouds? Enriched now with the heavier elements forged in the hearts of the first, short-lived giant stars and scattered by their explosive deaths? These enriched clouds, the raw materials for future suns and worlds, were also drawn into the growing gravitational embrace. They drifted, coalesced, swirling slowly towards the same subtle centers of attraction that were pulling in the stars. Imagine watching this unfold over unimaginable stretches of time. Not sudden collisions, but a slow, graceful convergence. Regions that started as slightly denser patches of the cosmic web began to pull in more and more material. Stars, gas, and the invisible underlying scaffolding of dark matter all were drawn together. The first tentative structures began to emerge, not yet the grand spirals we see today, but smaller, more intimate gatherings. Picture loose clusters, perhaps dozens or hundreds of stars, orbiting a common, invisible center of gravity. Think of them as the first hamlets, the first small villages appearing on that vast, dark plain. Within these nascent gatherings, a delicate dance began. Stars swung past each other in long, elliptical orbits, their paths constantly adjusted by the combined pull of all the others. Gas clouds, vast and diffuse, collided much more directly. As they bumped and merged, they lost energy, cooling and compressing. Shockwaves rippled through them, triggering new bursts of star formation. These second-generation stars, born from enriched material, were different from the very first pioneers. They contained traces of carbon, oxygen, silicon, the building blocks of complexity. Sometimes, within these early gatherings, incredibly dense knots of stars would form. Picture a swarm of brilliant bees, thousands, even hundreds of thousands of ancient stars packed into a relatively small sphere of space. These are the globular clusters, ancient relics that still orbit many galaxies today. Imagine them as the old city centers, formed early, densely packed with the universe's elder stellar citizens, glowing with a soft, golden light accumulated from countless aged stars. They are time capsules, preserving a record of those early, intense epochs of star formation. But the universe wasn't content with just villages and dense old towns. Gravity continued its patient work on ever larger scales. These initial clusters, these proto-galactic fragments, felt each other's pull across the intervening voids. Like streams flowing inevitably towards a river, they began to drift towards one another. The process was majestic, unhurried. Imagine 2 or 3 of these early stellar collections, each containing millions of stars, slowly spiraling towards each other over hundreds of millions of years. From afar, it would look like luminous clouds merging, intertwining, their stars mingling like raindrops joining a pool. As these larger structures merged, something beautiful happened. Just as a spinning skater pulls in their arms to spin faster, the combined systems conserved their angular momentum. If the merging fragments had even a slight initial rotation, that spin became more pronounced as they coalesced. Gas clouds, colliding and losing energy, settled downwards towards the spinning plane, flattening out like dough spun by a baker. The stars, while not colliding directly, had their orbits gradually coaxed and averaged out by the changing gravitational field, many of them settling into paths that circled within this flattening disk. And so, the first grand designs began to emerge from the cosmic chaos. Picture it, a vast, rotating disk of stars and gas, billions strong. At the center, where the density was highest, a bright, bulging core of older stars formed, a luminous hub. Stretching out from this core, within the spinning disk, patterns began to appear. These weren't solid structures, but rather slow-moving waves of density, like ripples on a pond or traffic jams on a celestial highway. As these waves swept through the disk, they compressed the gas clouds they passed through, triggering intense bursts of star formation along their leading edges. These waves, illuminated by the hot, young blue stars they created, became the spectacular spiral arms. Imagine these arms, graceful arcs of light and starbirth, swirling outwards from the galactic center. They are adorned with glowing nebulae, vast clouds of gas lit from within by newborn stars, painting the arms with strokes of pink and red. Dark lanes of interstellar dust trace intricate patterns within and between the arms, partially obscuring the light from behind and adding depth and texture to the view. Billions upon billions of stars, of all ages and colors, populate the disk, the central bulge, and a diffuse surrounding halo. It is no longer just a collection of stars, it is a city made of light, structure, and ongoing creation. Not all galaxies settled into this perfect spiral form. Some, perhaps formed from mergers with less initial spin, or whose gas was used up or blown away early on, became vast, smooth ellipsoids. Picture enormous, rounded or football-shaped collections of stars, often older and yellower, lacking the dramatic spiral arms and active star-forming regions. They glow with a more uniform, gentle light, like ancient, established metropolises, where the frantic construction phase is long past. Others remained small and irregular, perhaps disrupted by encounters with larger neighbors, or simply lacking the mass to organize themselves into a grander structure. They are the quirky, unique boroughs of the cosmic cityscape. Think now of the sheer scale of one of these stellar cities. Our own Milky Way, a beautiful barred spiral galaxy, is thought to contain perhaps 200 to 400 billion stars. Trillions of planets likely orbit those stars. It stretches 100,000 light-years across, a distance so vast that light itself, the fastest thing in the universe, takes 100 millennia to travel from one edge to the other. And our galaxy is just one among hundreds of billions, perhaps trillions, scattered throughout the observable universe, each one a swirling, luminous testament to gravity's patient artistry. Picture one now, hanging in the velvet darkness of space. See the brilliant core, the graceful sweep of the arms, the subtle glow of the halo. Imagine the countless stars within, each a sun, many with their own families of worlds. Feel the slow, majestic rotation, a cosmic wheel turning over aeons. Within its arms, clouds of gas continue to collapse, forming new stars that light up the interstellar binterstellar, not binterstellar dust lanes. Older stars complete their orbits, their light contributing to the overall glow. Occasionally, a massive star explodes, a supernova briefly outshining billions of its neighbors, seeding the surrounding space with newly forged elements, continuing the cycle of cosmic renewal. These are the star cities, the galaxies. They are the grand canvases upon which the universe paints with light and gravity. They are islands of structure and activity in the vast cosmic ocean. From the scattered embers of the first stars, gravity has built these magnificent, luminous metropolises. They are not static monuments, but living, evolving systems, constantly churning, building, and changing over billions of years. Rest now, picturing these swirling cities of light, these galaxies turning slowly in the quiet darkness, each one a universe of stars, born from the echoes of the Big Bang and the patient hand of gravity. The universe is no longer just lit by scattered candles, it is ablaze with the light of countless star-filled cities. Let the image of those countless swirling cities of light linger gently in your mind. See them turning, slow and majestic, scattered like luminous jewels across the endless, quiet velvet of space. Each one a testament to gravity's patient artistry, a vast collection of suns and worlds held in a delicate, cosmic dance. Now, let your focus drift, as if you were floating on a slow, invisible current through the intergalactic void. Let the multitude of galaxies recede, shrinking back into points of light, until one particular city begins to grow in your view. It's a beautiful one, a grand spiral much like many others, yet unique in its own right. From a distance, you can see the bright, elongated heart of it, a dense bar of older, yellower stars packed closely together, glowing with a steady, warm light. Around this core, graceful arms curve outwards, dusted with the brighter, bluer light of younger stars, and speckled with glowing pink clouds where new stars are quietly being born. These arms are not perfectly clear. Dark lanes of interstellar dust wind through them like shadowy rivers, partially obscuring the light from behind and adding depth and mystery to the view. This is our home galaxy, the one we call the Milky Way. It looks like a vast, luminous Catherine wheel, paused in its slow, billion-year turn. It hangs there in the quiet emptiness, a breathtaking island of light and matter. Let's drift closer still, not plunging into the fiercely bright and crowded central regions, nor wandering out into the sparse, lonely fringes. Instead, we'll navigate towards one of the calmer, quieter arms, a place nestled comfortably between the major thoroughfares of the galaxy. Imagine moving gently through the space between the stars. They pass by like distant streetlights on a foggy night, some brighter, some dimmer, some tinged with blue, others with orange or red. The space here isn't truly empty. It's filled with a thin, almost imperceptible haze of gas and dust, the raw material from which future stars, and perhaps even worlds, will slowly coalesce. It's mostly quiet out here in this galactic suburb, far from the energetic core. And here, amongst the countless other stars drifting in this arm, we find a very particular one. It's not the largest nor the brightest star around. It doesn't pulse dramatically or flare with unusual intensity. It's a rather average star in the grand scheme of things, a steady, reliable sphere of glowing gas, radiating a gentle, yellow-white light. It sits calmly in its pocket of space, diligently fusing hydrogen into helium in its core, as it has done for billions of years, and as it will continue to do for billions more. This ordinary, yet extraordinary star is our Sun, our very own star, the anchor of our small corner of the cosmos. Feel its steady warmth, even from afar, a constant, life-sustaining presence in the vastness. It shines with a dependable glow, a familiar beacon in the cosmic ocean. The Sun, like most stars, is not alone on its journey. Held gently but firmly by its immense gravity, a family of worlds orbits around it. They follow elliptical paths they have traced for aeons, moving in a slow, predictable, and silent ballet. This is our solar system, our immediate neighborhood within the vast Milky Way galaxy. Imagine the Sun at the center, a warm hearth, and these planets circling it at different distances, each unique, each following its own rhythm. The space between them is immense, a quiet, dark emptiness, yet they are all connected, tethered by invisible gravitational threads to their parent star. Let's draw a little closer to the Sun's warmth, into the inner part of this neighborhood. Nearest the Sun, we find Mercury, a small, rocky world. It spins very slowly while orbiting relatively quickly, enduring scorching heat on its sunward side and deep, freezing cold on its night side. It sleeps now, perhaps, bathed in the intense sunlight, or resting in the profound chill of its long night, a silent, cratered sphere keeping its own swift counsel. Moving just a little further out, we encounter Venus. Similar in size to our own world, it's permanently hidden beneath a thick, pale blanket of clouds. We cannot see its surface directly, only the swirling patterns in its dense atmosphere. It turns incredibly slowly beneath its veil, a world shrouded in mystery, perhaps dreaming hot, heavy dreams under its perpetual cloud cover. Its secrets are well kept, whispered only within its thick, insulating atmosphere. And then, at just the right distance, not too hot, not too cold, we find the third planet. A beautiful jewel of blue, white, green, and brown. This is Earth, our home. See the deep blue of the oceans covering most of its surface, reflecting the sunlight. See the swirling white patterns of clouds drifting lazily in the atmosphere, a much thinner, more breathable veil than Venus's thick shroud. See the patches of green forests and fields, the brown and tan of mountains and deserts. It rotates steadily, turning its face towards the sun for daylight and away into shadow for night, a gentle rhythm that rocks its inhabitants to sleep and wakes them again. Its thin atmosphere acts like a delicate, protective blanket, keeping the temperature mild and shielding the surface from harmful radiation. Life exists here, breathing quietly, growing, dreaming, sheltered by the air and the water and the gentle magnetic field. It's a cozy, living world, nestled in the perfect spot, a haven of warmth and life in the vastness of space. Feel its quiet hum, the gentle turning, the soft whisper of its oceans and winds. It rests peacefully on its journey around the sun. Just beyond Earth lies Mars, the red planet. Smaller than Earth, it has a rusty, dusty surface marked by giant, sleeping volcanoes and vast canyons carved long ago. Its thin atmosphere offers little warmth or protection, and the planet lies quiet and cold beneath a pale pink sky. It looks like a silent sentinel, patiently waiting, holding the memories of a time when water may have flowed freely across its surface. It drifts along its orbit, a tranquil, reddish neighbor in the quiet dark. Between Mars and the next large planet lies a wide gap, filled with countless chunks of rock and metal, the asteroid belt. These are not planets, but rather the leftover building blocks from the solar system's early days. They tumble slowly through space, following their own orbits around the Sun, like a scattered field of ancient rubble, quietly circling, posing no threat from our peaceful vantage point, just adding texture to the structure of our solar neighborhood. Moving further outwards, into the realm of the giants, we first encounter Jupiter. It is enormous, larger than all the other planets combined, a majestic king ruling the outer solar system. It's not solid like the inner planets, but a great ball of gas and liquid, wrapped in swirling bands of colorful clouds, creams, yellows, oranges, reds, and browns. Its most famous feature, the Great Red Spot, is a gigantic storm, wider than the Earth itself, that has been churning slowly and silently for centuries, like a deep, slumbering eye. Jupiter spins rapidly, a dynamic giant, yet its overall presence feels steady and watchful. Around it orbit dozens of moons, small worlds in their own right, like tiny pearls accompanying the giant on its slow journey around the Sun. Further still, we drift towards Saturn, perhaps the most elegant planet in our neighborhood. It too is a gas giant, pale, yellow, and banded, but it is adorned with a breathtaking system of rings. These rings are wide and thin, made of countless particles of ice and dust, ranging in size from tiny grains to large boulders, all orbiting Saturn together in a flat, shimmering disk. They catch the distant sunlight, glowing softly, creating an image of serene, silent beauty. Imagine the quiet ballet of these icy particles, circling their planet in perfect harmony. Saturn, with its magnificent rings and many moons, seems to float peacefully in the cold, dark space, a celestial jewel of quiet grandeur. Beyond Saturn lie the distant ice giants Uranus and Neptune. They are smaller than Jupiter and Saturn, but still much larger than Earth. They appear as beautiful, hazy orbs of blue and green, colored by traces of methane in their deep atmospheres. Uranus lies tipped over on its side, as if peacefully napping while it orbits the Sun. Neptune, the outermost of the major planets, is a deep, rich blue, marked by faint clouds and occasional dark storms that drift slowly through its frigid atmosphere. These two worlds are remote and mysterious, dwelling in the cold twilight far from the Sun's warmth. They circle slowly in the profound quiet of the outer solar system, like slumbering twins in the distant deep. Even beyond Neptune, our Sun's influence extends. Here lies the Kuiper Belt, a vast scattered disk of icy bodies, remnants from the formation of the solar system. Pluto resides here, once called the 9th planet, now known as one of the largest inhabitants of this distant realm. These icy worlds drift slowly in the near absolute cold, catching only the faintest glimmer of the distant Sun. This is the far edge of our sunny neighborhood, fading into the deeper darkness of interstellar space. So picture this entire system now, held together by the Sun's gentle, unwavering gravity. The small, rocky worlds huddled close to the warmth, the asteroid belt quietly tumbling, the magnificent gas and ice giants patrolling the colder regions, and the distant icy bodies marking the boundary. Each planet, each moon, each asteroid follows its ancient path, turning, orbiting, sleeping perhaps, under the watchful eye of our steady Sun. This is our cozy corner of the vast Milky Way galaxy, itself just one island universe among countless others. It's a place of relative peace and order, a familiar harbor in the immense cosmic ocean. Rest now, feeling the quiet, steady rhythm of our solar system turning slowly, peacefully, through the silent night of space. Now, let your awareness drift outwards, beyond the farthest icy wanderers of our own solar system, beyond even the shimmering band of our Milky Way. See our galaxy, that swirling collection of billions of stars, including our own Sun, shrink behind you, becoming just one island of light in an ocean of profound darkness. It rests there, a familiar shape turning slowly, held together by its own immense gravity, a place of relative closeness and connection. But as you float further into the quiet emptiness, you begin to notice other islands. Faint smudges at first, distant cousins to our own Milky Way. Some are spirals like ours, graceful arms pinwheeling through the dark. Others are soft, elliptical glows, like clouds of ancient starlight. Still, others are smaller, irregular shapes, scattered nearby. These are the other galaxies, countless cities of stars separated by gulfs of space so vast that light itself, the fastest thing we know, takes millions, even billions, of years to cross from one to the next. Imagine holding perfectly still in this intergalactic space, far from the pull of any single galaxy. You watch these distant islands of light. You watch for a long, long time. Longer than human lives, longer than civilizations. And you notice something extraordinary, something quiet and fundamental happening all around you. These galaxies, these immense star systems, are slowly, almost imperceptibly, drifting further apart from each other. It's not a chaotic scattering, like debris from an explosion flying outwards, through space. No, it's something more subtle, more profound. It feels as though the very space between them, the dark, empty void itself, is gently, persistently stretching. Think of an infinitely large piece of soft, dark fabric. The galaxies are like tiny, luminous threads woven into this fabric. Now, imagine the fabric itself is slowly being stretched in all directions. The threads themselves aren't crawling across the fabric, but the distance between them grows simply because the fabric between them is expanding. The galaxies are carried along by this underlying expansion, passengers on the unfolding tapestry of spacetime. This is the never-ending stretch of the universe. It's a slow, cosmic exhalation that began long, long ago and continues even now, in the quiet moments of this night. It's not a wind blowing through space, but rather space itself unfurling, creating more distance between things that aren't bound together by gravity. Our own solar system doesn't fly apart, because the sun's gravity easily overcomes this gentle stretch on local scales. Our Milky Way galaxy doesn't dissolve, its stars held tightly by their collective gravitational embrace. Even our nearest galactic neighbors, like the Andromeda galaxy, are actually moving towards us, pulled together into what we call the local group. Gravity wins in these denser, closer regions. But look further out, beyond the reach of these local gravitational ties. Look to the truly distant galaxies, millions and billions of light years away. There, the cumulative effect of this gentle, persistent stretching dominates. The further away a galaxy is, the more space there is between us and it, and therefore the more stretching occurs along that line of sight. This means the most distant galaxies appear to be receding from us the fastest. It's not that we are special. At the center of some outward rush, an observer in any other distant galaxy would see the same thing. All other distant galaxies moving away from them, as the space between everything expands uniformly. Feel this expansion now, not as a violent event, but as a deep, slow rhythm underlying the entire cosmos. It's the universe breathing, gently expanding outwards. It's a current so vast and slow that on the scale of our lives, even on the scale of our planet's history, it's almost undetectable. Yet, it is the fundamental state of the universe on its grandest scale. It carries the galaxies like silent ships on an invisible tide, slowly increasing the emptiness between them. The light reaching us from these distant, receding galaxies tells the story of this stretch. As light travels across the vast distances, the expansion of space itself stretches the light waves. Imagine a wave drawn on that piece of fabric we talked about. As the fabric stretches, the wave itself gets stretched out, becoming longer. For light, longer wavelengths mean redder colors. So, the light from distant galaxies arrives here, slightly stretched, shifted towards the red end of the spectrum. The further the galaxy, the more space the light has crossed, the more it has been stretched, and the redder it appears. It's like a whisper from across an immense distance, its tone lowered and deepened by the journey through expanding space. This cosmic redshift is the gentle signature of the universe's unending stretch, written in the very light of the stars. There is a profound quietness to this expansion. It happens in the silent vacuum, unnoticed by the busy lives within the galaxies themselves. Stars are born, they live, they die. Planets form and orbit their stars. Civilizations might rise and fall. All this happens within the galaxies, largely oblivious to the slow, majestic drift separating their entire island universe from others. It's a process operating on the grandest stage, a backdrop to all of cosmic history. Think of the sheer scale of it. This stretching isn't happening from a single point, it's happening everywhere. The space between your fingers isn't noticeably expanding, because the electromagnetic forces holding your hand together are vastly stronger. The space between the Earth and the Sun isn't expanding, because gravity holds the solar system firm. But the space between our Milky Way galaxy and a galaxy a billion light-years away is expanding, adding distance silently, second by second, century by century. It's a continuous unfolding, not a rush, but a steady, patient process. The universe isn't expanding into anything. Rather, the universe is the expanding space itself. It's a difficult concept to grasp, this idea of space itself having a dynamic quality, an ability to stretch and grow. But let the feeling wash over you, a sense of boundless immensity, not static, but alive with a slow, fundamental motion. Feel the deep stillness of the night around you. Now, imagine that stillness imbued with this almost imperceptible tension, this gentle, outward yielding of space itself. It's the quietest motion imaginable, yet it shapes the ultimate fate of the cosmos. It carries the light, stretches it, and determines the distances between the great galactic continents. It is the legacy of the universe's birth, a momentum that continues to shape its vast architecture. Rest in this awareness. The quiet turning of our solar system, nestled within the Milky Way, is a local dance governed by gravity. But beyond, in the great intergalactic ocean, the deeper music of the cosmos plays, the slow, steady rhythm of expanding space. The galaxies drift, carried further apart not by their own efforts, but by the gentle, persistent unfolding of the universe itself. It is a never-ending stretch, a silent cosmic breath shaping the immense and peaceful darkness. Feel the calm of this vast, slow movement, the quiet pulse of the expanding universe as you drift deeper into rest. And so, the quiet breath continues. The gentle outward yielding of space carries on, moment after moment, age after age. Imagine now, letting your awareness drift much, much further forward in time, carried on that slow, inexorable current. The galaxies, those luminous islands we see scattered across the cosmic ocean, continue their unhurried journey away from each other. The space between them stretches and stretches and stretches. Light from distant neighbors begins a journey it may never complete, its waves drawn out longer and thinner by the ever-expanding void, shifting redder and redder, fainter and fainter, like the last blush of sunset fading from the highest clouds. The universe grows quieter still. Within the galaxies themselves, the great clouds of gas and dust, the stellar nurseries where stars are born, begin to thin out. They are vast, but not infinite. Starbirth is a brilliant, energetic process, but it consumes its fuel. Over aeons beyond counting, the available hydrogen and helium are slowly locked away into stars, or blown clear by stellar winds and supernova explosions. The rate of new star formation dwindles. The vibrant, bustling galactic cities, ablaze with the light of young, massive, blue stars, gradually dim. The stellar nurseries grow cold and silent, their fertile dust settling, no longer collapsing under gravity to ignite new suns. The era of starlight, the stelliferous era, begins its long, slow twilight. Think of a vast forest after a long, dry summer. The vibrant green fades, the new growth ceases. What remains are the mature trees, standing tall but slowly aging. So too, the galaxies become forests of aging stars. The brilliant blue giants, profligate with their fuel, are the first to exhaust themselves, ending their lives in spectacular supernova explosions, leaving behind neutron stars or black holes, dense, quiet relics. Then the yellow stars, like our own sun, swell into red giants, shedding their outer layers in beautiful, glowing nebulae that dissipate into the thinning interstellar medium before finally collapsing into small, intensely hot but slowly cooling white dwarfs. These stellar embers, scattered like diamonds on black velvet, are the most common remnants. They shine brightly at first, leftover heat from their nuclear hearts, but with no fuel left to burn, they begin the longest cooldown imaginable. Imagine these white dwarfs, trillions upon trillions of them across the cosmos, slowly radiating their stored heat into the expanding void. They fade from brilliant white, through yellow, to orange, then to a deep, dull red, like coals left in a hearth long after the fire has gone out. Eventually, after timescales that dwarf the current age of the universe many times over, they cool further, becoming black dwarfs, cold, inert spheres of degenerate matter, invisible in the deepening gloom, detectable only by their gravitational pull. They are the quiet headstones marking where stars once shone. The red dwarfs, the smallest and most frugal of stars, burn their hydrogen fuel with painstaking slowness. They sip at their reserves, shining with a dim, ruddy light for trillions of years, far longer than any other star type. They become the dominant source of light in the aging universe, bathing the remnants of galaxies in a perpetual, deep red twilight. But even their fuel is finite. One by one, over unimaginable stretches of time, the last red dwarfs flicker and fade, their nuclear fires finally extinguished. They too cool down, eventually joining the silent ranks of the black dwarfs. The universe slips deeper into darkness, punctuated only by the occasional flare of merging stellar remnants or the faint glow from matter falling into the remaining black holes. The galaxies themselves are changing too. Pulled apart by the cosmic expansion, the great clusters and superclusters dissolve. Galaxies become increasingly isolated islands in an ever larger ocean of emptiness. Within the remaining galaxies, the orbits of the stars and their remnants slowly decay due to gravitational interactions and the emission of gravitational waves, faint ripples in spacetime. Some stars are flung out into the intergalactic void, destined to drift alone in the darkness. Others spiral slowly towards the galactic center, where supermassive black holes wait patiently. Over countless eons, the structured beauty of spiral arms and elliptical halos dissolves. Galaxies become diffuse, ghostly swarms of cold, dead stars, stellar remnants, and dark matter, dominated by the immense gravity of their central black holes. Picture this deep future, a universe almost entirely dark, almost entirely cold, vastly expanded. The distances between the decaying remnants of galaxies are immense, incomprehensible. Space is stretched so thin that the background radiation, the afterglow of the Big Bang, is cooled to near absolute zero, its wavelengths stretched beyond detection. Silence reigns, not just the absence of sound, but the absence of almost any energetic process. It is a state of profound calm, of ultimate stillness settling over the cosmos. Yet, even in this deep, cold night, subtle processes may continue, unfolding over timescales that make the lifespan of stars seem fleeting. If current theories hold true, the very substance of matter itself might not be eternal. Protons, the building blocks of atomic nuclei, once thought to be perfectly stable, may eventually decay. It's an incredibly slow process, perhaps taking 10, 34 years or even longer for a single proton to transform into lighter particles and radiation. But in the immense future of the Big Chill, time is abundant. Imagine the black dwarfs, those cold remnants of stars, slowly dissolving from within. Atom by atom, proton by proton, the matter that once formed suns and planets gently unravels, releasing faint whispers of energy back into the void. It's not a violent end, but a gradual fading, like an ice sculpture slowly sublimating into mist under a pale, distant sun. Mountains erode to dust, planets evaporate, even the most stable structures eventually succumb to this ultimate decay. The universe becomes an increasingly thin soup of elementary particles, photons, neutrinos, electrons, positrons, drifting ever further apart. Only the black holes seem to resist this dissolution, gathering the sparse remnants of matter that fall into their gravitational embrace. They become the dominant structures in this far future universe, massive points of gravity in an otherwise almost featureless void. But even black holes, according to Stephen Hawking's insights, are not truly eternal. They too radiate, incredibly slowly, through a quantum process known as Hawking radiation. They leak energy back into the universe, particle by particle. This evaporation is unimaginably slow for large black holes. A black hole with the mass of our Sun would take perhaps 67 years to evaporate completely. Supermassive black holes, residing at the centers of galaxies, would take vastly longer. Figures like 100 years are contemplated. Picture these cosmic behemoths, the last organized structures, slowly, gently radiating themselves away over timescales that defy human comprehension. It's like the final, faintest warmth emanating from the universe's dying embers. Each particle emitted carries away a tiny fraction of the black hole's mass, until, after an eternity, the black hole itself vanishes in a final, quiet burst of particles. And what remains then? The ultimate state of the Big Chill, the heat death of the universe. A cosmos expanded to unimaginable size, virtually empty, uniformly cold, approaching the stillness of absolute zero. All stars have long since died, all matter has decayed, all black holes have evaporated. What's left is a diffuse, featureless sea of low-energy photons, neutrinos, and perhaps other fundamental particles, drifting aimlessly through the near-perfect vacuum. All structures are gone. All processes have ceased. The universe has reached a state of maximum entropy, maximum equilibrium. There is no flow of energy, no potential for work, no possibility for complexity or change. It is the long, cool night, settled in for eternity. A state of profound peace, perhaps. The end of the cosmic story, not with a bang, but with the faintest, slowest, most gentle whisper imaginable, fading into an endless, silent darkness. The outward breath that began with the Big Bang has fully exhaled, leaving behind a vast, cold stillness. Rest in the awareness of this immense, slow journey, the universe unfolding through brilliance and fire, through life and consciousness, and finally, perhaps, into this ultimate, quiet peace. The great cosmic clock winding down, finding its final, deep repose. Yet, perhaps the final repose is not found in stillness alone. Imagine, if you will, a different quality to that outward breath, a different texture to the unfolding emptiness. Consider the expansion itself, the very stretching of space that carries everything apart. In the long, slow fade of the Big Chill, this expansion becomes almost imperceptible against the vastness, a backdrop to the slow decay. But picture, now, a universe where this stretching possesses a quiet, growing insistence. Not a violent surge, but a persistent, ever-deepening current within the fabric of reality itself. Imagine space as an infinitely large, impossibly fine piece of silk, being stretched steadily, smoothly, relentlessly. At first, the effect is subtle, noticeable only across the grandest scales. Those great clusters of galaxies, already islands in the cosmic ocean, feel the current quicken between them. The distances grow, not just linearly, but with a gentle, accelerating pace. It's like watching ships drift apart on a calm sea, their separation gradually but inexorably increasing, pulled by unseen tides. There is no collision, no drama, just a soft, inevitable parting of ways, each supercluster becoming ever more isolated, a lonely archipelago in an ocean expanding without end. The light from neighbors reddens further, stretches thinner, until eventually, no light can bridge the accelerating gulf. Communication, even by light speed, becomes impossible across these newly formed voids. Each cluster is sealed off, drifting alone into its own expanding horizon. Then, the gentle insistence of this stretching space begins to work on smaller structures. Within a single galaxy, like our own Milky Way, the subtle pull makes itself felt. The gravitational embrace that holds billions of stars in their majestic spiral dance begins to loosen. It's not a sudden break, but a slow, almost imperceptible yielding. Stars at the outer edges feel the outward tug most strongly, their vast orbits widening, spiraling gently outwards, like dancers slowly drifting away from the center of the floor. The galaxy doesn't fly apart, it elegantly dissolves. The beautiful structure, the spiral arms, the central bulge begins to lose definition, its components easing away from each other. Imagine a delicate web slowly expanding, its threads stretching, the points of connection moving further and further apart until the pattern itself dissolves into disconnected strands. Each star, once part of a glittering collective, is set adrift on its own solitary journey through the expanding darkness. The night sky within such a dissolving galaxy would change over unimaginable timescales, the familiar constellations warping, stretching, and finally fading as their constituent stars drift beyond view, one by one. The stretching continues, its influence reaching deeper. Now, consider a single star system, a sun and its planets. The gravitational tie between the central star and its orbiting worlds, a bond that has perhaps endured for billions of years, starts to feel the strain. The space between the star and its innermost planet stretches. The space between that planet and the next stretches. The orbits, once stable ellipses, begin to widen, to elongate. It happens slowly, gracefully. A planet might take centuries, millennia, to drift noticeably further from its sun, its year lengthening, the sunlight it receives growing imperceptibly dimmer. Eventually, the gentle, persistent pull of expanding space overcomes the star's gravity. One by one, planets are eased out of their orbits, not flung away violently, but softly released, like boats slipping their moorings. They become rogue worlds, drifting untethered through the rapidly emptying space between the dispersing stars. Moons, too, would feel this effect, their smaller gravitational bonds to their planets loosening until they too drift free, tiny solitary wanderers in the great expansion. Picture a solar system slowly unraveling, its members drifting apart like dandelion seeds caught on a persistent, gentle breeze, each finding its own path into the growing void. The insistence of the stretch deepens further still, working now on scales we consider solid and immutable. Imagine a planet, perhaps a rocky world like Earth, drifting alone after being released from its star. The expansion of space isn't just happening between objects, it's happening everywhere, even within the space occupied by the planet itself. The very fabric of spacetime that constitutes the planet's volume is stretching. At first, the electromagnetic forces holding rock and metal together, the strong and weak nuclear forces binding atomic nuclei, are vastly stronger than this subtle cosmic pull. But the expansion accelerates. The gentle tug becomes slightly less gentle, infinitesimally stronger with each passing moment. Eventually, there comes a time when the expansion across the diameter of the planet becomes strong enough to overcome the forces holding it together. It wouldn't explode. Rather, it would gently swell, then begin to crumble, not under impact, but from within. Mountains might lift softly from the surface. Continents might drift apart. The planet would slowly, quietly disintegrate, its constituent rocks and dust easing away from each other, yielding to the pervasive stretch. Any structure, no matter how solid, would ultimately be subject to this gentle, internal unraveling. And still, the expansion accelerates, its reach becoming ever more intimate. The focus narrows to the microscopic, to the very building blocks of matter. Consider the molecules that make up everything. The chemical bonds, the electromagnetic forces holding atoms together, are powerful on their scale. But the space within the molecule itself is stretching, pulling the constituent atoms apart. Like loosening threads in a tapestry, the bonds stretch, weaken, and finally give way. Molecules dissociate, breaking down into individual atoms. Water becomes separate hydrogen and oxygen atoms drifting apart. Complex organic molecules unravel into simpler components. All chemistry ceases as the space needed for atoms to interact and bond expands too rapidly. The universe becomes a diffuse gas of solitary atoms. But the process doesn't stop there. The gentle, accelerating insistence reaches within the atom itself. The electromagnetic force holds electrons in their orbits, their clouds of probability, around the atomic nucleus. Yet, the space occupied by the atom is stretching. The pull between the positive nucleus and the negative electrons weakens as the distance effectively grows. Eventually, the electrons are gently pulled free. Not stripped away violently, but eased out of their quantum dance, drifting away from the nucleus they once orbited. Atoms themselves are ionized, dismantled. The universe becomes a sea of free electrons and atomic nuclei, drifting ever further apart. Even the nucleus, that incredibly dense bastion held together by the strongest force in nature, is not immune. The strong nuclear force binds protons and neutrons together over incredibly short distances. But the space within the nucleus is also expanding. The relentless, accelerating stretch begins to work even here. Over time, the expansion across the tiny diameter of a nucleus becomes sufficient to overcome the strong force. Protons and neutrons gently, softly, drift apart from each other. The very heart of matter is undone. What happens then? Perhaps even protons and neutrons, composed of quarks, are subject to the final, ultimate, unraveling. Does the space between the quarks stretch until they too are pulled apart, defying the color force that binds them? This is the edge of speculation, the final moment of the Big Rip. The name sounds violent, but picture it instead as the ultimate, gentle release. Every connection, every bond, from the cosmic scale of galaxy clusters down to the subatomic scale of quarks, is softly, inexorably loosened by the ever-accelerating expansion of space itself. The end state is not one of cold, static equilibrium like the heat death, but one of infinite expansion and infinite dissolution. Everything, every particle, becomes causally isolated from every other particle, separated by truly infinite and constantly growing stretches of space. Each fundamental particle drifts utterly alone in a universe expanding at unimaginable speed. There are no structures left, not even atoms. There is no possibility of interaction. All forces have been overcome by the sheer scale and acceleration of space. It is the ultimate state of separation. Think of it not as destruction, but as a final, complete diffusion. A universe returned to its most fundamental, disconnected constituents, each one an island universe unto itself, drifting infinitely far from its neighbors in a silent, whispering void that grows without limit. The outward breath doesn't just exhale, it continues accelerating outwards forever, gently pulling everything apart until nothing remains bound to anything else. A final, soft, pervasive unraveling into utter simplicity and infinite distance. Rest now, contemplating this possibility, not an end of fire, nor merely of ice, but of a gentle, cosmic drifting apart, an infinite expansion into perfect, solitary freedom. The universe, in this telling, finds its end by becoming unbound. But perhaps that outward journey, that final, soft unraveling into infinite, solitary distance, isn't the only path the universe might tread. Perhaps the story doesn't end with everything drifting apart forever in a silent, ever-expanding void. What if there's another possibility, a different kind of quietude awaiting in the far, far future? Imagine, if you will, that the relentless outward push, the accelerating expansion driven by forces we still barely comprehend, is not immutable. Think of the universe not just as breathing out, but as capable, perhaps, of breathing in. Consider the ancient, persistent force that holds galaxies together, that keeps planets in orbit around their stars, that pulls an apple towards the Earth. Gravity. We see it overcome now, on the grandest scales, by the stretching of space itself. But what if gravity, that fundamental connection between all things with mass and energy, is playing a longer game? What if its influence, though seemingly diluted across cosmic distances, never truly vanishes? What if, like a thread stretched almost to breaking but still intact, it retains a subtle, persistent memory of togetherness? Picture the expansion, not as an eternal acceleration, but as something that might, eventually, begin to slow. Not suddenly, not with a jolt, but with an immense, unhurried gentleness. Over eons that make the current age of the universe seem like a fleeting moment, the outward rush could begin to soften. Imagine those farthest galaxies, their light stretched red by their rapid recession, beginning to show a slightly less pronounced redshift. The fabric of spacetime, stretched taut for so long, might begin to lose its tension, its expansion easing, decelerating almost imperceptibly. It wouldn't be a dramatic event, but rather a gradual yielding. The universe, having expended its initial explosive energy, and perhaps finding the mysterious dark energy driving the acceleration to be less potent than assumed, or perhaps even transient, might find its momentum fading. Like a ball thrown high into the air, reaching the apex of its flight, the cosmos could approach a point of maximum expansion, a moment of profound stillness, suspended between the outward journey and something else. Think of that turning point. A universe expanded to proportions almost unimaginable, vast beyond comprehension, yet poised. The relentless stretching pauses. For an age, perhaps, everything hangs in delicate balance. The galaxies cease their recession. The immense voids stop growing. A cosmic pause, a held breath lasting for billions, maybe trillions, of years. A silent, static universe, vast and cool, but no longer expanding. And then, slowly, tentatively, the return might begin. Gravity, the patient architect, always present, always pulling softly, could begin to reassert its dominance on the very largest scales. Not with a sudden snap, but with a gentle, inexorable insistence. The threads of attraction, stretched across billions of light-years, begin to draw things back together. Imagine the view from a hypothetical vantage point trillions of years hence. Galaxies that had been receding for eons would first appear frozen in the sky, their light no longer shifting further towards red. Then, over further immense stretches of time, they would begin to show the faintest hints of blue, the blue shift of approach. They wouldn't rush back, the distances are too vast for that. Instead, they would begin to drift, like continents on a slow tectonic plate, easing back towards each other across the cosmic ocean. The great voids, those near-empty deserts between galactic clusters, would slowly start to shrink. Galaxy clusters themselves, which had been moving apart, would halt their separation and begin a stately, almost reluctant, convergence. The universe, which had seemed destined for infinite separation, would start to draw itself back together. This wouldn't be a sudden collapse, not yet. It would be a reversal of the previous diffusion, a slow gathering, a gentle reaggregation. Think of dust motes suspended in a vast room, slowly settling back towards the floor. The universe, in this scenario, begins to settle inwards. The night sky, over unimaginable timescales, would transform. Distant smudges of light, the cores of other galaxies, would gradually grow brighter, larger, resolving into more distinct shapes as they drifted closer. Constellations, long distorted by cosmic expansion, might begin to compress, their member stars drawing nearer over the eons. The pervasive cold might slowly begin to recede, not dramatically, but subtly. As matter draws closer together, the average density of the universe, which had been plummeting towards zero, would start to creep upwards again. The background radiation, the faint afterglow of the Big Bang, stretched and cooled for trillions of years, might begin to warm, almost imperceptibly at first, as the universe compressing it reverses the stretching effect. This process, this slow, gentle drift back towards intimacy, is sometimes called the Big Crunch, but perhaps that name evokes too much violence, too much suddenness. For the initial stages of this cosmic homecoming, think of it instead as a great sigh. The long outward breath of expansion finally ceases, and a slow, equally long inward sigh begins. The universe, having explored the limits of its expansion, turns back towards its origins. It's a process of reunion, unfolding over timescales that dwarf everything that has come before. Structures that had dissolved or dispersed might slowly reform. Gas clouds, drawn together by gravity, could begin to coalesce anew. Perhaps, in this far-distant contracting phase, conditions might even allow for new stars to form, briefly illuminating the contracting cosmos before they too are drawn into the general convergence. The feeling would not be one of impending doom, not for a very, very long time. It would be one of increasing proximity, of decreasing emptiness. The ultimate isolation of the Big Rip scenario is replaced here by a slow, inevitable reduction of distance. The universe becomes less lonely, more crowded, but with an almost infinite slowness. As the contraction progresses, accelerating gently under gravity's relentless pull, the universe would indeed become denser and hotter. The galaxies, once islands in an endless sea, would begin to merge more frequently. The average temperature would rise, slowly reversing the long cooling trend. the sky would grow brighter, filled not just with stars, but with the increasingly warm glow of the background radiation, blue-shifted now instead of red-shifted. Eventually, yes, this path leads to a state of extreme density and heat. Galaxies merge, stars are drawn closer, eventually colliding or being torn apart. Atoms themselves might be broken down as the temperature and pressure become immense. The universe could, in its final moments, return to a state reminiscent of its very beginning, a hot, dense plasma collapsing inwards towards a single point. The big crunch, the final moment of the inward sigh. But dwelling on that final, potentially fiery point misses the beauty and wonder of the journey towards it. The wonder lies in the possibility of reversal itself. The idea that the universe is not necessarily committed to eternal expansion and dissolution, but might possess an inherent tendency towards reunion. That the fundamental forces could conspire not just to push everything apart, but eventually, gently, patiently, to draw it all back together again. It speaks, perhaps, to a different kind of cosmic balance. Not the cold equilibrium of heat-death, nor the infinite separation of the Big Rip, but a cycle. An outward breath, followed by an inward one. Expansion leading, eventually, to contraction. A universe that might not end, but simply transition, perhaps even rebound into a new beginning. So, as you rest, contemplate this alternative destiny. Let your mind drift across the truly unimaginable timescales. Picture the slowing, the pause, the gentle turning of the cosmic tide. Imagine the slow drift back together, the universe sighing inwards, gathering itself after its long journey outwards. It is not a certainty, merely a possibility, a different dream the universe might be dreaming, a dream of return, of convergence, of a final, all-encompassing embrace. A universe not fading into infinite separation, but perhaps, just perhaps, finding its way back home. Rest in that thought, the quiet possibility of a great, cosmic sigh. Let that thought settle, like fine dust motes catching the last ray of light in a quiet room. The possibility of a universe breathing in, a slow return after an age of expansion. It's just one dream the cosmos might be dreaming, a whisper among the vast silences. Now, let your awareness drift beyond these grand finales, beyond the ultimate fate, whether it be fading embers or a gentle homecoming. Let it float back through the immense, unhurried story that has already unfolded, the story that surrounds you, even now, in the quiet darkness. Think of the beginning, not as a violent explosion, but as an awakening, a point of infinite potential, stirring from an unknowable sleep. Imagine a silent unfolding, a blossoming of light and energy into the waiting void. The first light, stretching out, beginning its journey across distances that would soon become truly, staggeringly vast. This initial moment, this genesis, wasn't a frantic rush, but perhaps a deep, cosmic exhalation, the first breath of spacetime itself. Feel the quiet awe in that beginning, the pure potential from which everything, absolutely everything, would eventually arise. Picture the universe in its youth, a swirling canvas of cooling gases, hydrogen and helium, the simplest elements, drifting like mist in the immense darkness. There were no stars yet, no galaxies, just vast ethereal clouds, patiently gathering, drawn together by the faintest whispers of gravity. Imagine floating within these primordial clouds, surrounded by a soft, uniform glow, the afterglow of creation itself, slowly dimming, slowly cooling, like embers left from a fire that lit up the entire sky. There is a profound peace in this early simplicity, a universe unwritten, holding all its future wonders in quiet suspension. Then, slowly, almost imperceptibly, over millions upon millions of years, gravity begins its gentle work. It nudges particles together, encourages wisps of gas to find each other, to coalesce. Imagine these vast clouds beginning to curdle, to form denser regions, like cream rising in milk. No sudden movements, just a slow, persistent gathering. These are the seeds of galaxies, the first hints of structure emerging from the smooth infant universe. It's a process of immense patience, a cosmic artistry sculpting matter on the grandest scale, guided by invisible, fundamental forces. Feel the quiet insistence of gravity, not as a harsh pull, but as a gentle, organizing principle, bringing order out of the initial homogeneity. And within these gathering clouds, smaller pockets begin to form, denser still. They pull inwards, spinning slowly, warming up. These are the protostars, the nurseries where the first suns will be born. Picture them as glowing embers within the vaster, darker clouds, points of nascent light. The pressure builds, the heat intensifies, until deep within their cores, a new fire ignites. Nuclear fusion begins, and the first stars blaze into existence, scattering the primordial darkness. Imagine that first starlight, pure and brilliant, traveling outwards, illuminating the surrounding gas, beginning the long cycle of stellar life and death. It's not a violent birth, but a necessary one, a point of transformation where simple gas becomes a radiant engine, creating heavier elements in its fiery heart. These first stars live fast, burn brightly, and die spectacularly, seeding the surrounding space with the new elements they forged. Carbon, oxygen, iron, the building blocks of future worlds, and indeed, of you, scattered like dandelion seeds on a cosmic wind. Think of these stellar deaths not as endings, but as acts of profound generosity. The universe enriching itself, becoming more complex, more capable of bearing intricate structures. Imagine the expanding shells of gas from these supernovae, glowing nebulae painted across the darkness, filled with the dust of expired suns. These nebulae are not scars, but rather fertile grounds, repositories of potential, waiting for gravity's gentle hand to gather them anew. And gather they do. Gravity pulls these enriched clouds together, forming new generations of stars, stars like our own sun. And around these new stars, disks of leftover gas and dust begin to swirl. Picture these protoplanetary disks, vast, flat rings of matter orbiting their young suns. Within them, tiny dust grains stick together, growing into pebbles, then boulders, then planetesimals, slowly, patiently building worlds. Imagine the quiet ballet of accretion, particles gently colliding and merging, growing over millions of years into planets, moons, asteroids. Rocky worlds close to the star, gas giants further out, each finding its place in the developing system. There's a quiet orderliness to it, a cosmic construction project proceeding at its own unhurried pace. Think now of the galaxies, these immense islands of stars, gas, and dust, wheeling through the cosmic ocean, billions, perhaps trillions of them, scattered across the observable universe. Picture our own Milky Way, a vast spiral disk, a river of stars flowing through the night. Imagine its slow, majestic rotation, taking hundreds of millions of years for one complete turn. See the spiral arms, regions of active starbirth, glowing with the light of young, hot stars and colorful nebulae. See the central bulge, a dense concentration of older, yellower stars orbiting a supermassive black hole, a quiet, gravitational anchor at the galaxy's heart. Feel the immense scale, the countless stars held together in this graceful structure, drifting through the intergalactic void. It's a city of light, humming with the quiet energy of billions of suns. Consider the spaces between the galaxies, the vast stretches of near emptiness. But even this void is not truly empty. It's filled with faint whispers of gas, stray stars flung out from their homes, elusive dark matter holding structures together, and the faint, ancient light from the universe's dawn, still traveling after billions of years. Imagine this deep, quiet space, not as barren, but as profoundly peaceful, a place of deep silence, where light travels for aeons undisturbed. It is the canvas upon which the bright galaxies are painted, the necessary darkness that allows the light to shine. Rest in this vast, quiet, this deep background hush of the cosmos. Think of the light itself, the starlight traveling across unimaginable distances to reach us. The light from the nearest stars is years old. The light from distant galaxies has journeyed for billions of years. When you look up at the night sky, you are looking into the past. Each point of light is a messenger from a different epoch, carrying stories of stars long dead, of galaxies as they were when the universe was younger. Imagine this ancient light, traveling patiently through the void, carrying the faint signature of its source. It's a connection across time, a whisper from the deep past, arriving at your quiet moment of rest. Let this ancient light bathe your awareness, a gentle reminder of the universe's long and enduring story. Contemplate the cycles. Stars are born, live, and die, returning their substance to the interstellar medium, which then forms new stars. Galaxies collide and merge, triggering bursts of star formation, reshaping themselves over cosmic timescales. Perhaps the universe itself cycles, expanding and contracting, or perhaps undergoing transformations we cannot yet conceive. There's a rhythm to the cosmos, a pattern of creation, existence, and transformation, playing out on scales both small and unimaginably large. Feel this gentle rhythm, like a slow, deep heartbeat, underlying all the complexity and change. It's a rhythm of persistence, of continuity, even through dramatic events. And within this grand, unfolding story, you exist. The atoms that make up your body, the carbon, the oxygen, the nitrogen, the iron, were forged in the hearts of stars that lived and died long before the Earth was formed. You are, quite literally, made of stardust, a child of the cosmos. Feel that connection, not as an intellectual concept, but as a quiet, physical truth. The substance of your being is woven from the fabric of the universe's history. As you rest, you are part of this immense, ongoing process. Your quiet breathing mirrors, in its own small way, the cosmic rhythms of expansion and creation. You are a temporary, intricate pattern formed from ancient matter, contemplating the universe that birthed you. There is so much we don't know. The nature of dark matter, the mystery of dark energy driving the accelerated expansion, the ultimate fate we pondered earlier. The universe still holds deep secrets. But perhaps this uncertainty is not cause for anxiety, but for wonder. Like looking out over a vast, misty ocean, we see the nearby waves clearly, but the horizon remains shrouded, full of possibility. Embrace the mystery. Let the unanswered questions be part of the beauty, part of the dream. The universe is not a problem to be solved, but a vast, evolving story to be witnessed, to be part of. So, let your mind drift now, like a solitary spaceship coasting through the quiet interstellar dark. Let go of the need to understand everything, to grasp the entirety of this immense narrative. Allow yourself simply to float within it. Picture the soft glow of distant nebulae, the gentle turning of spiral galaxies, the patient journey of ancient light. Feel the deep silence of the void, the immense peace of cosmic scales. The universe is vast, ancient, and filled with wonders both seen and unseen. It proceeds at its own pace, governed by laws that are both elegant and profound. There is no need to strive, no need to grasp, just rest. Let the quiet majesty of the cosmos be a lullaby. Feel the pull of sleep like a gentle, cosmic gravity, drawing you into stillness. Imagine your consciousness expanding outwards, merging with the quiet darkness between the stars, finding a profound sense of peace in that infinite expanse. The universe has been unfolding for billions of years, and it will continue its journey long after this moment. You are a part of that journey, a fleeting, precious awareness within the grand cosmic dream. Allow yourself to sink into that dream now, into the deep, restorative quiet. Let the story of the universe cradle you as you drift off, surrounded by the silent, sleeping stars. Rest now. Sleep now. Become part of the quiet, cosmic night. And so, the grand story draws to a quiet close for tonight. We've journeyed together across unimaginable stretches of time, from a beginning so dense and hot it's hard to truly picture, to the vast, cooling expanse that might lie in the furthest future. We saw the first light break free, watched as tiny ripples grew into the seeds of galaxies, and marveled as stars ignited, fusing simple elements into the building blocks of everything we know. We saw those stars live out their brilliant lives, some exploding in spectacular supernovae, scattering their precious creations across space, while others collapsed into mysterious black holes, holding their secrets close. We saw galaxies form and cluster, dancing slow, gravitational ballets over billions of years. And we peered into the distant future, considering the possibilities, a universe continuing to expand and cool until the last stars fade, or perhaps other. stranger fates hidden in the mathematics and observations we're still gathering. It's a story of such immense scale, spanning distances we can barely chart, and timescales that make mountains seem fleeting. It can feel overwhelming, like trying to hold the entire ocean in a small cup. But just like the ocean is made of countless tiny drops of water, this vast cosmic narrative is woven from simple, understandable processes governed by laws that we are slowly, patiently deciphering. The same gravity that holds you gently in your bed keeps the planets in orbit and pulls gas clouds together to form new stars. The same light that travels from your bedside lamp to your eyes is akin to the ancient light from distant galaxies that tells us their stories. Think about the atoms that make you, the calcium in your bones, the iron in your blood, the carbon that forms the basis of your cells. Almost every single one, except for the very lightest elements forged in the Big Bang itself, was created deep inside a star that lived and died long before our own sun even formed. You are, quite literally, made of stardust. The universe isn't just something out there, vast and separate, it's also right here, within you. That incredible journey from the first moments to the formation of galaxies and stars is also your own origin story, written in the very substance of your being. The ultimate fate, those far-off possibilities we spoke of, whether it's a slow fade into quiet darkness or something else entirely, is so incredibly distant. Billions upon billions, even trillions of years from now. It's a timescale so vast that it slips beyond our grasp, like trying to count every grain of sand on every beach. It's part of the story, the final chapter perhaps, but it's a chapter so far removed from our present moment that it belongs more to the realm of quiet contemplation than immediate concern. It's like knowing that even the tallest mountain will eventually erode away, but still appreciating its majestic presence today. What matters, here and now, is the universe we can see and experience. The moon hanging in the night sky, reflecting the sun's gentle light. The planets tracing their paths across the constellations. The countless stars scattered like diamonds on dark velvet, some near, some far, each a sun in its own right, perhaps with its own family of worlds. Even the darkness between the stars isn't truly empty. It's filled with faint whispers of the past and the potential for future wonders. There is so much beauty, so much intricate detail right now. And there is still so much we don't know. Our understanding of the universe is like standing on the shore of a vast ocean. We've dipped our toes in, mapped the nearby currents, but the deep mysteries remain. What is dark matter? What is dark energy truly doing? Are there other universes? These aren't gaps to be feared, but invitations to curiosity. They are the parts of the story still waiting to be written, discoveries waiting for future generations, perhaps even fueled by the dreams of those listening quietly right now. Science is a continuous journey of discovery, peeling back layers, asking new questions as old ones are answered. It's a testament to the enduring human spirit of exploration and wonder. So, as you lie here, feeling the gentle pull of Earth, remember that you are part of this immense, unfolding story. You are a child of the cosmos, living on a beautiful blue planet orbiting a stable, middle-aged star in a quiet corner of a vast galaxy. The universe, in its grand evolution, created the conditions for you to be here, to think, to feel, to wonder about it all. Let the vastness outside be a comforting blanket, not a source of unease. The silence of space can echo the quiet in your room as you prepare for sleep. The distant, fading light of ancient stars can be a reminder of the long, slow, peaceful processes that govern the cosmos. The mysteries that remain can be like unopened gifts, holding the promise of future knowledge. The story of the universe, from its fiery birth to its potential quiet end, is ultimately a story of transformation, of cycles, of energy changing form. And now, it's time for your own small, peaceful cycle, the transition from wakefulness to sleep. Let your thoughts drift, like nebulae in the cosmic currents. Let your breathing be slow and steady, like the orbits of the planets. Close your eyes and let the darkness be a canvas for dreams, perhaps filled with swirling galaxies or quiet, starlit nights. The universe will continue its grand, slow dance while you rest, and you are a precious, thinking, dreaming part of it all. Sleep now, little stardust explorer. sleep peacefully. And so, the story of everything, from its first tiny fiery breath to its long, slow exhale, unfolds across unimaginable stretches of time. It's a story so vast, painted on a canvas so wide, that our own lives, even the lives of everyone who has ever looked up at the night sky, seem like the briefest flicker within it. But even the briefest flicker is part of the light. Think of all those moments we talked about: the initial flash, brighter than anything we can truly picture, the slow gathering of gas and dust into the first stars, like cosmic campfires igniting in the dark, the swirling dance of galaxies, great islands of light separated by oceans of quiet emptiness. Billions upon billions of years passed, galaxies collided and merged, stars were born in fiery nurseries and died in spectacular bursts, seeding space with the very elements needed for new stars, new planets, and perhaps new life. It's a grand slow-motion ballet performed across the stage of spacetime. And here you are, now, breathing quietly in the soft darkness. That breath you just took, the warmth of your skin beneath the blankets, the gentle rise and fall of your chest, all of it is connected to that immense story. The calcium in your bones, the iron in your blood, the carbon that forms the very structure of you, all of it was forged long ago in the heart of a star that lived and died before our own sun even began to shine. You are, in the most literal sense, made of stardust. Imagine that, particles that traveled across light years, across eons, have come together, right here, right now, to make you. You carry the history of the cosmos within you. It's not just a story out there, far away. It's woven into the fabric of your being. The universe has its own clock, ticking in billions of years. Our human clocks tick much faster, in seconds, minutes, days, and lifetimes. It might feel strange, thinking about timescales so different from our own. But perhaps it's comforting, too. It means that the universe moves with a deep, unhurried rhythm. The changes we spoke of, especially those far, far in the future, the slow cooling, the stars eventually fading one by one like distant embers, they are part of that rhythm. They won't happen tomorrow, or next year, or even in a million lifetimes. They are destined for a future so remote it's almost beyond imagining, like trying to picture the color of silence. When we talk about the end, whether it's the long, slow fade of the Big Freeze, where everything drifts apart and cools into darkness over trillions upon trillions of years, or other possibilities scientists ponder, it sounds perhaps a little sad, like the end of a beautiful song. But think of it less as an ending, and more as a transformation. The universe, in its own way, is simply following its nature, its energy slowly spreading out, becoming quieter, more diffuse. It's like the ripples on a pond slowly smoothing out after a stone is thrown, until the water is calm and still again. It's a process so gradual, so gentle on the scale of the cosmos, that it's less like a sudden stop and more like a slow, peaceful descent into a deep, quiet sleep. And even as we tell this story, based on everything we've learned by looking through powerful telescopes, by studying the light from distant galaxies, by thinking deeply about the laws of physics, we know it's not the final, complete picture. There are still mysteries we haven't solved, questions we haven't even thought to ask yet. Our understanding grows and changes, like a slowly developing photograph. Future generations will look deeper, understand more, and perhaps tell the story in a slightly different way. That ongoing quest for knowledge, that gentle unfolding of understanding, is part of the wonder, too. It means the universe still holds secrets, waiting patiently to be discovered. So, as you lie here, feeling the gentle weight of the blankets, listening to the quiet sounds of the night, let the vastness of the story settle peacefully around you. It doesn't need to feel overwhelming. Instead, let it be a reminder of the incredible journey that led to this moment, right now. The universe expanded, stars burned, elements were created, planets formed, and eventually, here, on this small, blue world, you came to be, able to think and wonder about it all. The quiet darkness outside your window mirrors the vast quiet between the stars. The steady rhythm of your breathing echoes the ancient, slow rhythms of the cosmos. You are a part of this immense, unfolding story, a precious, thinking, feeling part of the universe looking back at itself. The atoms within you have traveled further and seen more than you can imagine. They were there in the early universe. They were forged in stars. They drifted through nebulae, and now they are here, composing you, dreaming your dreams. Let your mind drift now, like a tiny spacecraft sailing through the quiet void. Let the immense timescales and distances become soft, like clouds blurring at the edges. The story of the universe, from its bright beginning to its distant, quiet future, is ultimately a story of change, of energy transforming, of matter rearranging itself according to deep and elegant laws. And right now, the most important part of that story is your own peaceful rest. The universe will continue its slow, grand journey, but your journey tonight is into sleep, into dreams where perhaps you can float among the stars you're made of. Close your eyes, feel the calm descend, and know that you are connected to everything, a small, warm spark of consciousness held safely within the vast, gentle darkness of the cosmos. Sleep now. Sleep peacefully.